Hello everyone. Let's look at today's Leetcode problem 2016, maximum difference between increasing elements. Before starting this problem, let us look at a motivational quote for today. You cannot control others, but you can control how you react. That's your real power. Even in learning, one might face unfair feedback from friends, people who discourage or doubt you. You cannot always change how others act upon you, or what they say, or how things happen around you. You can only control your response to criticism by your attitude, discipline, and focus. You can focus on your growth and not distractions. And that's the real power that we all have. Okay, so let us look at the problem statement. Given a zero indexed integer array nums of size n, find the maximum difference between nums of j and nums of I and nums of j. Uh, Nums of j minus nums of I such that 0 is such that I is less than j and nums of I is less than nums of j. So that's the whole goal. Return the maximum difference if no such I and j exists. Return minus 1. Okay, so here if we consider uh, I as this one, and we do not see any elements of j greater than nums of I, which is no elements are greater than, so we cannot 7 minus, we cannot subtract anything with j. So zeroth element is out of consideration. So if we go to I is equals to 1, then we can see 1, and we need to iterate this way, as our base condition is I should always be less than j. So we can uh, have for loop I to n, and for j loop is equals to I plus 1 to n, right? So, and we can add in two conditions. I is less than j, which will obviously be true with this part of initialization, and we can only have nums of I is less than nums of j. So with this condition, we can keep track of a max difference, and we can constantly check math.max. Okay, so that's the whole idea. So we can obviously look at the example too, but it's more or less the same. But yeah, let's uh, plan for our solution of how we would try solving this problem. So we can have a brute force approach where I 0 to n stands for length of the array, and for j is equals to I plus 1 to n, and we can only check if nums of j is greater than nums of I, and we also keep track of a max difference initially at 0, and we always, or we can have it as minus 1 as per the expectation of problem. If there is no such ij, return minus 1. So considering that statement, we can keep max difference minus 1, and every time we can check max difference, comma, uh, nums of j minus nums of I. right? So that's the whole thing, and then we can return, and this would be time complexity of n into n and space complexity of 1, while we can have another optimal approach where uh, let's say initially we keep track of with nums of 0 as the minimum initially, and the max difference also we can set it as -1, and we can have only one for loop where j, which runs from 1 to n, and we can check if nums of j is greater than nums of I, then we can calculate the max difference is equals to math.max between max difference or nums of j minus nums of I. Else, min element so far will be equals to num of j, right? And so on. And then we can, at the end, we can simply return the max difference. This would be our approach. Okay, let's code this approach and let's try solving this problem. Okay, so this should be our solution. Let's try submitting the solution. As you can see, the solution gets submitted. Time complexity of this solution would be O of n, as we are iterated through the num's length, and space complexity is 1, as we do not have any variable memory space. Okay, so if you found this video helpful, please like and subscribe to my channel. Thank you.